let's say, colleague, an excellent professor, visiting professor, and an excellent professional in general, dear Fotis and Dr. Fotis Filippopoulos. Fotis has been collaborating with our university in the MSc in Strategic Product Design for many years as a visiting professor in design thinking courses, in innovation management courses, which is an expert in these fields. Currently, Fotis is a visiting professor in the Politecnico di Milano in the doctoral school. And also he's now head of the Innovation Lab in KPMG Greece in Athens. And Fotis has a very big experience in the European and international level, especially in European Union in the industrial policy. He has been a contributor for many years. And today he's going to talk his expert session. He's going to talk about design thinking for AI and sustainability. I think it's going to be very interesting his talk, and I think it's going to create a very fruitful discussion after that. I think Fotis, the floor is yours. We're expecting this talk. Thank you very much for joining today, and you can start. Thank you very much.
Thank you. Thank you so much for the introduction. Remind me of your bank account to send you the money later. Welcome to the expert session. Thank you so much for the invitation. It's such an honor for me to join you. Thank you to Ms. Kiskini. Thank you to Professor Gedges for this honor. Today we're going to talk about design thinking for AI and sustainability with the intent to unlock strategic value and competitive edge. And of course, how do we actually do that? Let me share my screen. And please confirm that everything is okay. It looks good.
Yes, Fotis. Yes, perfect.
Excellent.
Yes.
So welcome. This is a very special moment for me. It's a special moment, not only because I joined forces again for one more time with beloved colleagues, but also because my life has fundamentally changed during the last 2 months as I joined as the lead of the KPMG Intelligence Lab of KPMG Greece. It's a lab where we are working with mostly industry leaders in order to accelerate learning and increase the innovation capacity of businesses and organizations. KPMG is a global enterprise, as you might know, with 150 years of history and presence all over the world, more than 140 countries, with 275,000 employees globally. In Greece, the presence is equally analogically strong, with 4 offices in Thessaloniki, Heraklion, Crete, and Athens. This is where I'm based, and it has almost 850 employees, and this number, to the best of my knowledge, keeps increasing. And with that being said, let's jump into the actual topic of today's expert session. Today's agenda consists of those key elements that can help us understand what design thinking is at a grassroots level, how AI, this revolutionary technology, can help us increase our innovation capacity from the perspective of design thinking, and of course, to achieve our sustainability targets. We're going to talk about design thinking. We're going to talk about design thinking for sustainability. We're going to discuss the promise of AI, where we are, its origins, and where it's heading. We're going to dispel some of the myths, of the common myths, and then we're going to join all these concepts together with design thinking for AI and sustainability. Well, as one of my favorite scholars said, Herbert Simon, a Nobelist in economics, said that everyone who devises courses of actions aimed at changing existing situations into preferred ones. So whether you like it or not, when you do something, you are designing. Now, if you are designing the right things or the wrong things, that's another subject. So what is design thinking? Design thinking is a mindset. It's a human-centered, possibilities-driven, options-focused, iterative problem-solving method. It is the intent behind the outcome. So when we want to design an outcome, it is the intent behind this outcome. And of course, all this mindset, the approach and the methodologies that we apply in order to reach this final stage. There are many models available for design thinking, depending on the organization that practices them, and of course, the background of the organization. One of the most famous examples is the Stanford one, because it is related with this esteemed design organization IDEO, therefore they're using their own model. However, because agility and the essence of iteration is part of the DNA of this methodology, we can see many other models that pretty much are all the same. However, with a few tweaks. There is the Columbia model, the Stanford model, the IBM model, the IDEO model, and this is the MIT model, which is my favorite one because of its simplicity. Usually it consists of 5 steps. This is a 4-step process. First, we need to understand the problem. And how do we understand the problem? By empathizing with our user. By empathizing, we mean pretty much one thing: primary market research. The second step involves turning this understanding into possible solutions through brainstorming and developing ideas for our prototypes that we're going to test and refine in the later stages. And considering that, given that these prototypes provide the promise of desirability, feasibility, and feasibility, financial feasibility, then we implement and grow it as a product or service. Well, design thinking is not new. So whoever tells you that design thinking is a new, modern, fresh methodology, that's plain wrong. So design thinking in tech years is pretty much an ancient methodology. We can trace back its origins to the 1940s with the first psychological studies in the area of productive thinking, for example. Then it has evolved into, it has moved into other domains like engineering, where we had the first papers on creative engineering in the 50s and systematic method for designers. So we moved from psychology into the engineering domain because engineers needed to find a systematic way of innovating, meaning a repeatable way of innovating, meaning a more scientific way of innovating. Because science is something that can be tested, it can be repeated, and it can be validated or not. So this is what science is. Then we have the main evolution. This is like a big stepping stone for design thinking in the 70s and the 80s, where we have the emergence of the idea of wicked problems. So wicked problems are those problems that are very hard to define. There is no stopping into them. There's no beginning, there is no end. We don't know whether they are right or wrong, and we don't know their size. So there are many unknown variables when we analyze them. And this is where theory comes in and defines them as wicked problems. And this is exactly the reason why they are wicked. Then, of course, wicked problems evolved into human-centered design. And later we have in the 2000s the modern applications that most of us are aware of today, the famous IDEO models and the service design from the 90s, and then the mass publicity gained by scholars and authors like Tim Brown with books like Change by Design and so forth, and the design of business by Roger Martin. And today, of course, we have the worldwide adoption, and it has become the golden standard for human-centered service design and product design practices taught pretty much all over the world. It is important when it comes to creativity, and what I'm going to say now, it usually takes me 32 hours to explain it properly. It is the art and science and the practice and the craft of thinking inside the box, not outside the box. And to be more precise, to think inside the box that you've just created. In design thinking language, we call that framing the problem, because there are so many variables, so much data out there. It is very important to develop the skill of understanding the problem, defining the problem, and in order to understand it. So to frame the problem, first of all, you need a wicked problem, you need a pioneering technology, and you need a radical solution. And at the same time, you need to develop something that is viable, something that is desirable, and something that is feasible. And in order to answer all of these questions, you need a group of people that combine different skill sets. Finance people are those that define whether or not our solution is viable. Marketing people and market research is the practice that tells us if it's desirable or not. And engineers are the ones that tell us if it's feasible. And it is so hard to achieve those three objectives at the same time. It's like trying to shoot an arrow through three different circles that move into space and to actually hit them in the middle where they join. That's why we call it in the design language the wow zone. So wicked problem, radical solutions, pioneering technology, meet viability, feasibility, and desirability. And those conditions are the ones that allow us to develop really breakthrough solutions. These are the very characteristics, the DNA of breakthrough solutions. Something that is big enough and something that is feasible, viable, and desirable. Speaking of problems, design thinkers consider problems as opportunities and not as problems. Therefore, the word problem does not exist in the design thinking world. We are only thinking about opportunities. And this is where actually businesses, modern businesses, innovators find windows of opportunity in order to grow. You need to identify, to find problems. And problem finding is a key ability. As one of my favorite inventors of all time, Charles Kettering, said, a problem well stated is a problem half solved. Just think about it. How many times in your lives have you encountered a wicked problem and actually you solved it much faster because you simply were able to define it, to understand it, to frame it. Therefore, a problem well stated is a problem half solved. So design is about problem finding and problem solving. And in more modern terms, it's about need finding, not problem finding. Because not all problems are made equal. There are big problems, there are small problems. There are problems that are faced at mass by the society, and these are problems. However, if that problem is evident in just you, yourself, or a single person, then it's not a problem, it's an issue. Therefore, we need to know if it's an issue or a problem. If many people have the same issue, then that issue is a problem. Then there are also the interesting problems. In money terms, generally speaking, in the startup world, we are looking at 100 million and up as a total addressable market. Therefore, interesting, when I say the word interesting from now on, it has to worth 100 million and up. And moving on, this is the πλοήγηση στην ασάφεια. Just to learn a little bit of Greek, is the navigating ambiguity. How do you navigate something that you don't know? How do you navigate a scene, a domain that you have little information and you don't know the outcome. You don't know what are the false positives, the false negatives are. You don't know how to define it. You don't have any historical data to back up your solution. So how do you navigate ambiguity? That's extremely hard to do. However, thank God, we have solutions for that. Design thinking is one of them. So navigating ambiguity for very good reasons. It has been identified and flagged as the super ability of designers. And according to a recent Stanford study, if I remember the source correctly, very recent, I'm talking about less than 5 years old study, they found that the biggest ability of all nowadays is the ability to navigate ambiguity and to make sense of the events, the sense-making ability, as we call it. So navigating ambiguity is something very specific. This is not mumbo-jumbo Mickey Mouse theories. If we double-click on the word navigating ambiguity, then underneath we have a set of abilities that help us navigate ambiguity. It's as simple as that. Therefore, if those design abilities that you see underneath are the notes, then navigating ambiguity is the song. And the key skill set that is required from us to become effective designers before we move into the sustainability issues, because that comes later, is A, learning from others, people and environments. The second ability is rapid experimentation. And my favorite personal quote is, experimenting is the best type of thinking. Information synthesis, something that you can do nowadays with AI, and I'm going to explain that towards the end. Purposeful communication, meaning that to frame the problem, to know what you're talking about, and you have a purpose when you are communicating your design outcomes or design objectives. To move between concrete and abstract, that's a very, very important skill. Intentional construction and creation, and finally, to design your design project. That's a meta ability where allows you to, it's the ability that allows a designer or a group of designers, to be more precise, to actually design their design project. That's the intent behind the outcome. Therefore, before I move on, these are the notes, and navigating ambiguity is the song that you play with these notes. Of course, it's not that easy, because we human beings, after the Neanderthals, the Homo sapiens sapiens, our species, have embedded human errors in our brain architecture. And deepening our experience with design thinking can help us ensure that those biases don't become obstacles to innovation. And there are 3 categories of biases. I'm not going to be very detailed on that one. I'm going to just name them. So the first category is where the error lies in the information that we process. And of course, there are various ways to mitigate those category 1 errors. Then we have category 2 errors, where the error lies with those that we are designing for, since the error lies in us as human beings. And the third type of category of biases, is that all of this information is, let's say, biased because of the way that we think. Therefore, knowing how these biases play in the way that we understand, collect, analyze, synthesize information in design, it is very important to apply the mitigation factors, knowing, for example, biases like a hot or cold bias. We say one thing, we change, for example, our preferences depending on our psychological state. Confirmation bias, and so forth. It's like a whole list. Very important. Now, the big question, is design thinking effective? We know from studies that specifically from the Design Value Index, that design-driven organizations, those organizations that design their processes, design their products and services based on design thinking, they can be up to more than two times, they can outperform their competition by 2 times. Companies like Apple and so forth. Therefore, yes, it is very effective, provided, of course, that you are practicing it correctly. Now, design thinking for sustainability. What is different with this? So what exactly does it mean? First of all, as we said, that is the intent behind the outcome. So these are not just phrases, these are guiding principles in our design of the design work. We know from this is a very famous proliferate statistic, that 80% of a product's environmental impact is determined by its design. Therefore, we can actually save that from the environment by designing it from the beginning. And this is very important to consider the environmental effect of our designs before we actually design the product, and not as an after the fact effect, or as an afterthought, even worse. So design thinking for sustainability similarly has specific notes that we need to play in order to create the song. The first step is that we meet with all the affected parties, all of them, not only the customers, but also the providers, the vendors, governments, local communities, everyone that we feel that is affected by the specific design, by the specific solution. And then we identify the needs and business activities. This is where empathy comes in. Easier said than done. So empathy is a very overused word. Many people use it, few people can actually practice it. You need to know what you're doing, you need to know how to practice empathy, how to conduct primary market research, and then how to synthesize this information in order to create practical, actionable insights. The third step is to understand the problem, meaning to frame it, in order to spark new thinking through empathy that came from the step before. And then we synthesize this information for action in order to develop certain prototypes that can help us solve the specific problem of sustainability that we're trying to solve. Then we test it, and then we implement it as agreed by the wider stakeholder group. And finally, we raise maximum value from the new product throughout the life cycle. Therefore, we are not considering only the design phase, but we are considering also the entire life cycle of the product, of the solution. How do we come up with the idea? How do we identify the problem? How do we come up with the idea? How we prototype it? How we develop it into a product? And then how we dispose it, and so forth. Of course, considering that 80% of the environmental impact is defined by the design phase. Now, I've done my best. It's not easy to find excellent examples of the applications of design thinking for sustainable solutions. However, I did my best, and I found a couple here that can inform our expert session. The first example comes from one of the best companies in the world, very esteemed, IDEO, a design company that actually partnered with H&M to develop new plastic-free packaging systems. And by systems, we mean that it's not only a certain solution, but also a system of packaging. Very smart, very smart. So how did they approach the problem? First of all, they have identified the overall problem, that packaging represents 26% of the plastics produced worldwide each year. So it is a huge problem. It is a wicked problem. Fashion e-commerce is estimated to grow by 10% through these days. Therefore, it is a big pressing problem that is likely also to grow in the future. And solutions like these are very important for the sustainability of the planet, of our society. So this is what they did. They have 100 million plastic-free packaging has been processed worldwide, and 2,000 tons of plastic eliminated by H&M operations. So it was a very effective solution developed by EITO by developing these packages that you've seen here. Let's take a look at the video. So this is how they developed the system. They came up with, they understood the company, they understood the problem, they understood their needs, and they came up with a system, multiple packaging solutions that can be applied on multiple types of products sold by H&M with this astonishing result. So this is a great example. Another example is how can we apply business model innovation for sustainability. So it's not only about developing sustainable products, that's one thing. The other thing is how can we incorporate it in our business model, as H&M did in their operations, in this case, on the esteemed new brand. I would say it's not new, but it is a star riser, let's say, in the sports industry. I love this brand for its design, for its engineering. It's for those that are not familiar with it, it comes from Switzerland. And basically they have introduced, to the best of my knowledge, one of the first, if not the first, subscription model for shoes. So how does it work? This is the Cloud Neo shoe. You're ordering it and you're keeping it for a certain amount of time, then you return it, and then you get another one. That's it. First, you subscribe, then you wear them, then you order the next pair within a specific time frame. And they have also developed an app that tells you when the shoes should be changed. Amazing, isn't it? This is works of genius. It's not only smart business. This is genius that we are looking at here. Another example is PillPack. Great example, love this example. It was an online pharmacy that is now purchased. It was acquired by Amazon Pharmacy, now it belongs to Amazon. So basically the problem that they solved was, this is an MIT startup, is that all the people keep forgetting to get their pills because they have to get many pills, different types of pills in different types of the hour and different types in different days. So it's like it can get complicated. Therefore, through specific algorithms, they have developed this personalized, let's say, package that comes in those rolls of pills that tells you, you just rip it out and it tells you that you have to take this, let's say, pack of pills this specific time of the day. Another work of genius. That saves, of course, packaging and all the rest. Works of genius. So, design thinking for AI and design thinking with AI. I would say it is part of the same thing. For AI is basically applying design thinking to develop AI-based solutions, and design thinking with AI is when you actually apply AI in the design thinking process. Revolutionary technologies. So the digital revolution is over. When I hear nowadays in 2025 about digital revolution, I want to pull the rest of the remaining hair out. The digital revolution is over because we are living already in a digital society. It's done. Of course, the digital revolution came with winners and losers. We all know the winners. It's TikTok, OpenAI, Netflix, BitTorrent, Airbnb, YouTube, Google, LinkedIn, and so forth. Unfortunately, nobody talks about the losers because history is written by the winners. So every 2 days, according to Eric Smith, we create as much information as we did from the dawn of civilization until 2003. This is a mind-blowing statistic. So what's next? What's the next revolution? We have all been promised lately since to 2022, the revolution that AI will bring. That AI is the new basis for business creation, service design, and reinvention. According to MIT, AI refers to the development of systems that can perform tasks typically requiring human intelligence, such as reasoning, learning, and problem solving. That's the official definition offered by MIT. So the idea, however, of an alien, superior, or an artificial intelligence is not new. Since the dawn of humanity, people have imagined superior, alien, or artificial intelligences that come and destroy the world, or they come and they take over the world, or they come to protect us. One of the oldest stories is actually Talos, comes from the ancient Greek mythology, which is this mythical robot. Actually, all of these graphics are made by AI, by the way. So Talos was a huge bronze robot that was patrolling up and down the island of Crete in the ancient times, and protecting the island. And it used to kill, they say, the myth says, the enemies by hugging them and becoming, very hot and burning the enemies. So that is one of the earlier, let's say, ideas of an autonomous automaton. Then, from the ancient Greek times all the way to the medieval times, with Ramon Lull's Ars Combinatoria, which is the idea of coming up with ideas, with concepts by moving disks that combine different concepts and ideas together. It's a physical machine, paper disk, that allowed these combinations of concepts. Pretty much like this. Again, this is AI generated, but it is very accurate, and I love it. So you combine the concepts like this. We also had cases of snake oil, as usual. The mechanical Turk, which is a 18th century chess playing automation created by Wolfgang von Kempelen. That was actually a hoax. It had a real human chess master, a small one, hidden inside this box. And the objective was to fool people that this was an automated chess playing machine. So this is the story of the mechanical Turk. So all the way from ancient philosophies to medieval first practices to mechanical Turks and AI snake oil, here we are today. And today's super technologies, which are real, very real, and technologies that are changing our lives, and technologies that play a huge role, not only in design thinking, but also for sustainability. So these super technologies are evolving around product and service ecosystems. And those products and service ecosystems allow technologies to be deployed and scaled, such as IoT and edge computing, so Internet of Things and edge platforms. And for those that may be not familiar with edge, by edge computing, we mean the solutions where the actual computing and the processing of information takes place at the local basis for speed, agility, and lack of, let's say, loss of time. Cloud servers, of course, cloud technology is a fundamental technology. Digital twins that make deep inspection simple and feasible, and mixed reality that creates new user interfaces. And of course, we have AI, which provides autonomy. And it doesn't stop there. By AI, it's a huge domain. We have, for example, human behavioral simulation. There are already platforms out there, such as AI per Mind, that allows you to simulate interviews. And we, as researchers, have already started experimenting with human behavioral simulation, and we are going to actually do that. We're going to extend this practice and speed up this practice as part of the KPMG Intelligence Lab. Computer vision, which is a huge subject. And if you look at the Google Scholar rankings, you're going to see that computer vision is the second most popular scientific field right now. So from all the AI ecosystem, computer vision is the most popular or proliferate, and from all sciences overall is number 2. So this is how important computer vision is. We have, of course, robotics, and robotics and AI didn't used to be together. Now they are coming together. They have been separated for more than 50 years, since the 70s, mainly because of there are many reasons behind it. I'm not going to spend too much time on that. One of them is because of the different math that they are using. So AI uses discrete math, whereas robotics use fuzzy sets. So different types of math behind them. And that caused basically, along with the other reasons, of course, for robotics to move into the mechanical engineering domain and AI to computer science. And now, 50 years later, through the multi-tier architecture technology, those two are coming together finally. And now we can actually confidently, at least, or despite being the early days, put together in the same phrase robotics and AI. AI Internet, such as Model Context Protocol, or the so-called MCP, that's not the only one. There is a huge discussion about it. And many scholars have different opinions, conflicting opinions, what is going to be the future in order to allow for agentic AI to become a reality. Such as agent-to-agent, different types of protocols. Physical AI, the same thing that happened with the internet. Back in the early days, late 90s, for example, people, believe it or not, didn't think that the AI is going to break into the physical world, and it did. The same thing will happen with AI. It's not going to be just something digital, but it's going to be located with sensors and physical devices all around us, and we can already see that becoming a part of, increasingly becoming part of our daily lives. Agentic AI, which is, again, not something new. As AI is 75 years old since the 50s, agentic AI is 40 to 50 years old. And of course, generative AI, which is the AI that we have experienced since 2022. It is important, before I move on and join all the concepts together of design thinking, AI, and sustainability, to explain a few things about the origins of AI in order to dispel the myths. So before the 1950s, there was nothing. There were myths, there were taluses, there were snake oil, there were mechanical turks, there were paper discs, things like that. The era of optimism was in the 50s, where we had the first, let's say, the term AI was coined during the Dartmouth conference. We have also the Turing test by Alan Turing. I mean, the Turing test is a test that allows us to understand without being able to see whether or not you're interacting with a machine or a human. And if you're not being able to distinguish who is who, then we can say that this AI system has passed successfully the Turing test. Then we have the early chatbots with Elisa and the Seiki robots in the 60s, Mycin in the 70s. This is huge. It was a solution for the biomedical sector that allows us to understand what type of disease and so forth based on specific yes and no's. It was a tree-based logic. It didn't fly, it wasn't adapted because it was too early. Then we have the first AI winter in 1974 till the 80s, meaning that there were no further developments in AI. Then we have the first summer of AI with the expert systems in the 80s. Then we have again a second winter in the 80s to mid-90s, and then, of course, modern spring, 90s, 1993 till today, with AlphaGo, deep learning, and so forth. And nowadays with the large language models, and you can see how many models there are, and this is a pretty old, let's say, depiction. There are many more now. So it's growing. Now, the puzzle of AI, when it comes to our field and what we do care about, is that A, we have to consider that it is the fastest technology adoption ever. 100 million users in 2 months. Okay, that is the biggest record. Specifically, to be precise, the first one is Threads by Meta, but in 5 days it reached 100 million users, but it leveraged Instagram's 1.2 billion user base. So if we exclude that, plus that they made it default that you can start an account with Threads. If we exclude that, then ChatGPT is the fastest growing AI app ever in history, reaching 100 million users in just 2 months. TikTok, it took it 9 months. Instagram, 2 years and 6 months. MySpace, 3 years. And the further back you go, the longer it takes. As you can see, the speed nowadays that the development of happening it's an astonishing, mind-blowing pace. We have mass attention versus a few big T business transformation, and this is the actual puzzle of Gen AI. Despite the fact that we have the fastest technology adoption ever, mass attention, we have very few big transformations, big T. Why is that? The key question is, where is it? Where is the transformation around us? Everybody's using it, but where are the transformations? Will Gen AI help us to grow our business, reduce costs, differentiate, develop and launch faster, happier employees, transform industries, roles and functions? Many things, but where are they? Let's look at the adoption before we answer this question. So organizations, yes, indeed, they have adopted Gen AI. You can see the graph is on the up. Same thing across functions and throughout the years. Whether it is 1 function, 2 functions, 3 functions, we can see that the adoption is picking up pace. And in this graph, we can see that mostly professional services, technology for marketing and product service development are the ones up there, and to the left are the areas that AI has really sped up pace, whereas other sectors are slower to adapt, but sooner or later they will pick up pace. Now, the biggest related risk, the greatest related risk is of course inaccuracy, cybersecurity issues, intellectual property, compliance, regulatory compliance. Big organizations especially have this issue. They don't want the info, the intellectual property leaking into the internet or be used to train other models. Of course, nowadays, ChatGPT, Gemini, and other famous LLMs, Claude, and so forth. I don't want to exclude anyone. Perplexity. They all have specific, let's say, specifications that allow you not to train the models based on that. So many of these fears have been mitigated. For example, inaccuracy has been mitigated through the application of RAG models, the retrieval augmented generation, means that it's connected with the internet. Therefore, the hallucination parameter can be reduced. It is more, let's say, accurate. And of course, the better they become with more data and better training, newer models, and so forth. Now, the big lies of AI. As told to executives, A, we are ready to deploy AI, most likely you're not. AI can solve all our business needs, not at all. Our data is clean. Data cleaning is one of the most arduous and time-consuming activities that you can do when you exercise, when you are practicing AI and executing an AI project. We need more data. That's not entirely true. We can deploy AI systems like all other systems, not at all. That is a different thing, game-changing. We have all the performance we need, and so forth. However, those transformations that AI has promised us are on the way. They are coming. And they call it the era of great reprioritization. where AI will be just one piece of the puzzle. It can be combined, and it is already being combined with other technologies to reinvent our processes. And speaking of the AI where we are now today, we can all trace it back to this very paper by Google researchers. This 2017 paper called Attention is All You Need. So in the Attention is All You Need paper, they have, what's different? They have developed the transformer architecture that has changed completely the way that we interact with AI. And it's the reason why we have AI as, let's say, a mass applicable tool today. So what we are, most of the tools that we see and use now in our everyday lives are based on the transformer architecture. So is the transformer architecture the dominant design for generative AI? I'm going to explain that from an innovation management point of view later. Let's see how it works. So, first of all, ChatGPT and other LLMs, unlike the older models that process the words one by one, they use attention mechanisms to analyze entire sequences, allowing us to understand complex relationships, generate coherent and context-aware responses, and of course to predict language at a very unmatched scale. Now, one of the best visualizations to explain how LLMs work is by 3 blue, 1 brown. This amazing visualization explains the process and the attention mechanisms in the generative AI transformer architecture. So, first we have the tokenization of embeddings, where we input text that is broken into tokens. Each token is mapped into a vector and into a high-dimensional space. Then we have the attention mechanism that weights those relationships between the words. Then we have the feed-forward layers that refine the meaning. Each layer deepens the semantic relationships and improves our prediction. Then we have the iteration and deep learning, where the process repeats through dozens of or even hundreds of layers, adjusting the token embeddings. And this is where the deep learning happens. And then in the last stage, we have the prediction and sampling, which is the final vector representation and generating word by word on a context basis, considering, of course, the overall context of the content. And how can we explain what happened in 2017 in the light of innovation leadership? This is Foster's S-curve. This is the most prolific and most accepted theory in all social sciences. So on the vertical axis, we have technological performance, and on the horizontal axis, we have time. In the beginning, we have the era of ferment, where we have many different variations of the same technology, of the same thing. Then, in order for this technology solution to grow, we need to reach that inflection point, often defined by what we call the dominant design, the golden standard for this technology. For example, the dominant design of smartphones is the iPhone. Then we have the sustaining innovations, where we are pushing the technology up the curve, better camera, faster, thinner, smaller, better battery. And then we have the maturity phase that is defined by the physical limits. And then we jump to the new technology. Why is it an S-curve? Nobody told me that when I was younger. I hope that there was someone to explain these things to me. But here we are, explaining this thing to you. It is an S-curve because no matter whatever technology you look at, it takes an S-curve shape. And you can see these are fundamental technologies, microwaves, TVs, and so forth. So whether the adoption is fast, whether it is slower, it always follows this S-shaped curve. And as a nerd sidebar for the nerds watching, this is the most widely accepted finding in all social sciences. So considering this, the dominant design of generative AI could be, there is a huge discussion about that, the transformer architecture. So from CDs, from LPs to CDs, from CDs to the internet, from the video stores to Netflix, and from Netflix to, who knows, is it Google Veo, is it Showrunner? Let's take a look at Showrunner, for example. Could this be the future of Netflix? So basically, right now, we have the streaming services. We just log in and we see what others have produced for us. With AI, this can change by producing whatever we want through a prompt. Create me this type of show, make me a movie for that. And this future is not very, very far away. We can see that the quality and the capabilities of AI-generated videos is astonishing. So this is Veo by Google DeepMind. And this is just a fraction of the examples. We could spend all evening for that. Another important paper that has led humanity to where we are now, there are many, but these are the ones that I have isolated, is the Improving Language Understanding by Generative Pre-Training that presented the original GPT model by OpenAI. And that's a 2018 model. So the big development happened in 2017 and 2018 that we see now. And the language models are Few Short Learners by Brown and others at 2020. That introduced the GPT-3 model, which is basically the model that we experienced as the early model in ChatGPT. So how AI is redefining innovation-driven enterprises? And in 5 minutes approximately, I'm going to be open for any questions that you might have. So what is innovation, first of all? Innovation is invention multiplied by commercialization. This is my favorite definition by MIT professor Bill Olet. So innovation can be anything from an invention, can be an idea, an IP, a new technology that is taken to market. And it's multiplied because if one of the two is zero, then you don't have innovation, you have an invention waiting somewhere at a university lab. And commercialization is all about, of course, finding a problem, finding a person that is willing to pay for our solution. Therefore, innovation is a commercialized invention. So, human in the loop, centaurs and cyborgs. This is where the term is taken from the esteemed professor in the field of AI, Ethan Mollick, who separates, let's say, the tasks that we do with AI between the just me tasks, the ones that we do by ourselves alone, to the centaurs, as you know, the mythical beast of the ancient Greek times, that is half horse, half human. So the distinction is very clear when we are moving from AI to just me activities. Clearly, there's a clear distinction, all the way to cyborgs, that basically activities that we perform in conjunction with AI throughout the process. And in order now to apply AI for sustainability within design thinking, of course, we need to combine the main capability sets of the two, of us and of AI. We offer the empathy, the understanding, the creativity, the innovation, the intuition, the consciousness, whereas AI offers the processing speed, the consistency, the diverse perspective, multitasking, rapid experimentation, and so forth. And design thinking for sustainability comes, again, the notes that we need to play in order to play the song of AI for sustainability are, again, meeting with all the parties, identify their needs and business activities, understand their problems, synthesize the information, prototype and test the solutions that we develop based on this information, implement as agreed by the whole group, and then, of course, to retain and grow and to scale as a solution. And AI comes specifically for brainstorming, data synthesis, and prototyping. According to IDO, again, when we ideate without AI, we can see we have all experienced that curve. That basically we have great ideas, yeah, fantastic idea, and then there's a decline before there is a breakthrough. Whereas with the use of AI, we can actually shorten this process and reach the desired output, a fantastic idea, much shorter because of the iteration factor, because of the processing speed. And let me give you an example. So I asked Gemini to make me rich, give me an idea, without any capital, no commitment and no effort. And Gemini comes up with something like this. Capitalize on your skills, think scalable. That is not very helpful. We need to know how to apply, how to use AI. And we can actually put it to good use. Within the space, within the frame of design thinking, and speaking of space, how can you can ask it, how can I design a toothbrush for astronauts? Something that is a wicked problem. You don't have any data, you don't know anything about astronauts, you need to empathize, you don't know anything about the environment, zero gravity environment, conditions, and so forth. And there you are, boom, we have a specific sets. And through AI, we can actually develop a very quick prototype that we can, of course, kickstart the spiraling innovation process. And AI also helps us within the design thinking framework that, of course, the desirability is one thing, the feasibility is another, and we also have the viability factor, whether it is a business. Okay, fantastic, but is this a business? And then we have the rise of new tools. One of the top, I would say the top tool that I've encountered and is the MIT AI Jetpack that is revolutionizing the business development research by developing a platform that can take you through all the MIT 24 steps of finding the idea, empathizing all the way to conducting primary market research, finance parameters, whether there is a market, what can you do for your customer, how do you do it, viability, all the way to prototype and then market development in one go. So AI can actually compress the IPDD, the innovation and product development depth, meaning the time, the cost, the energy that we spend in order to develop a new solution. And that takes us for the next 5 minutes before I finish, bam, on time, is the rise of AIDEs, the rise of the AI-driven enterprises. This is the idea of this graphic is taken, the graphic is mine, but the idea is taken by the work of Bill Olet, an esteemed professor and beloved professor at MIT, and Paul Chick, the director of the MIT Entrepreneurship Center at the Massachusetts Institute of Technology. So how AI is redefining innovation-driven enterprises? First of all, we have the SMEs. We need to define the distinction between those types of enterprises. So we have the SMEs, the small, medium enterprises, where the delta T is short. By delta T, we mean the reaction time from the time that you invest to the time that you have an actual income. That is actually very short. The focus here is on local economies. And of course, you need less investment and you have early revenue. Similarly to the SME exporters, very important enterprises, small, medium enterprises are the backbone of the European economy. However, innovation-driven enterprises are rather different. They have longer delta T, meaning that it takes longer to respond. They require more investment. They provide later revenue. The focus is global. The jobs are tradable, meaning that you can actually set up an office here and you can have workers all over the world. And of course, you have an innovation at the very core of the business. And the key characteristics, as you can see, is the innovation and product development depth, meaning that you are starting by losing money till you actually find product market fit and then grow and become viable. A process that can take years. However, with AI, because of the processing speed, because of all these characteristics of AI and capabilities. The AI-driven enterprises that have AI in their processes, they work with AI, they develop with AI, they think with AI, they have high innovation, they have lower risk because of the rapid experimentation that AI allows, they require less headcount, they allow for rapid and continuous product development, they have a global focus, much like IDs, and they have orders of magnitude of financial, let's say, returns. It's like 5 million per person as a revenue. And of course, they reduce the innovation and product development debt, the IPDD, by a lot. A great example is Lovable, a Stockholm-based AI-driven startup that reached 10 million in ARR, annual recurring revenue, in just 2 months. And some people say, I don't know if this is media friendly or whatever, but they say that maybe we are going to have the first single person billionaire within our generation. That's what they say. I'm just repeating it. So my call to action to you is to develop your emergent design thinking and AI sustainability skills. And by emergent, this is a key concept coming from physics. They call it the emergent abilities, emergence. So small quantitative changes can lead to qualitative changes in behavior. So what are your emergent behaviors? What small changes can you add to the way that you work, to the way that you design, in order one day to emerge into something better, something bigger? So the possibilities are endless, and they are all ahead of us. Thank you so much for your attention. If you want to know more about me, if you want to contact me, if you want to see what we are doing, you may visit the KPMG Intelligence Lab at kpmg.com.gr services, KPMG Intelligence Lab. You can actually scan the QR code. And of course, you feel free to contact me or connect with me on LinkedIn, on this link. You can find me as Fotis Filippopoulos, and my name is Fotis Filippopoulos, PhD, on LinkedIn. You can scan the code. So thank you so much for your attention, and I'm all ears in case you have any questions. Thank you.
Thank you very much, Fotis. That was a storm of information that you provided to us, as always, of course, when you give some talks and speeches. I don't know if we have any information from the people from the audience about any specific question about design thinking, the interrelation and the interoperability between those technologies. If anyone would like to make a question. Anybody?
The meeting, I cannot see any question in the chat. However, I believe that Mr. Filippopoulos was, wow, so much information that the participant might need some time to, to think about it and maybe come up with questions.
Ms. Kiskini, there is a name for that. It's called drinking from the fire hose.
Okay. Great. Yes, thank you very much for your presentation. Maybe we can wait for a while. I don't know.
I can start with some questions to you, Fotis. I mean, okay, that was wow. Okay, as Corina said, thank you very much. I would like to ask. I mean, in Europe, okay, we have certain regulations, the Green Deal, the Artificial Intelligence Act, and all those things. Okay, at the company level, we can see the different companies that try to implement those design thinking. What about regulations? I mean, at the European level, since we're talking about an Interreg program here, what will happen with those regulations? I mean, do they stop the European companies to growth, to develop? I mean, and all this, the majority of information comes from United States. Let's say the examples, IDO and all these companies. What happens in Europe? and how we can, the regulations with the companies, how can they develop growth, to design new products, and let's say to create business as well. Yes.
Yes. Well, Lovable, for example, is a European company. It is the fastest growing one, AID. Certainly. When you design your design work, first of all, you look at the regulations. And when you are designing with AI or for AI, definitely you need to check if there is data, you need to check the regulation, you need to check, of course, the compliance issues, depending on the organization that you're working at. And therefore, in the very, very first step that I mentioned, that you have to bring in all the affected parties, yes, part of these stakeholders are everyone affected, meaning that it can be your organization, it can be your user, it can be the local government, and so forth. Therefore, we do need to consider definitely the AI Act, which is a risk-based approach. So it's not, the AI Act is not here to stop innovation, AI-related innovation or AI-powered innovation from happening. It is a framework that allows us to understand what level of risk is acceptable and at what level. So what we can do and what we cannot do. So it is a guiding principle, and it is an evolving legal framework. It's not something set in stone. Therefore, yes, you do need to consider what you can do. GDPR, AI Act, local compliance issues, local government, EU law, and of course the organizational parameters, because you might work in an organization that might not be ready yet for AI. That is why we apply frameworks called AI readiness assessments, where we assess how ready each organization is to apply AI, not only from a legal standpoint, but also from a skill-based standpoint. You need to have the people as well. You need to have the processes. You need to have the mindset. You need to have the culture. And of course, all that, somehow you have to place it within the frameworks, the law, and so forth. That's why framing the problem is very important, to think inside the box. It's a skill. It's a skill. So from now on, if somebody tells you think outside the box, you might say, think again. Think outside, think inside the box that you've just created.
Okay. We have one question from the audience, from Rosina, but before we go to that, Fotis, one second question. As an academic, okay, what I find out is that a lot of people are talking about AI and in relation to computing, in relation to all these things. How we can provide this knowledge at a business level to the students, okay? Because what we have provided here, okay, we have done that in the past to our MSc bit, okay, but at a European level, how we can give that knowledge to non-technical students, okay? Because what we have provided today is you de-escalated this knowledge, okay, to business people, I mean, to different, let's say, levels. Yes. At education level, how we can do that, okay? I don't think there are many courses that can provide that at the European level.
Yes, there are practical applications, practical skills. One of the key practical skills that I would advise to practice and to actually develop specific workshops, specific case studies that you can work on, is to guide the students, for example, within the design thinking, to apply AI in brainstorming, data synthesis, and prototyping. So you need to develop some kind of, if you have real data or develop AI-generated data, teach them how to analyze it, and so forth. And that being said, if we double-click on that skill, on navigating, let's say, ambiguity with the use of AI, is, of course, to develop the prompting skills, prompt engineering skills. You have to know how to talk to the AIs meaningfully and to get the desired outcomes. So these are all very practical skills that can be taught. Okay. And they are being taught.
Okay. Thank you for this. Corina, shall you go through to these questions that we have on the chat?
Yes, I will read the first question from Rosina Giordano. Thank you. to Mr. Filippopoulos. May we have your opinion about the sustainability side of AI in terms of resources consumption, water, critical materials, etc., and emissions? Using AI for sustainability, isn't it a bit ironic in a way, inside parentheses? And say thank you.
Yes, that is an excellent question. Excellent question. Yes, AI is consuming a lot of energy. And in the US right now, which is, let's say, an environment, an economy that moves much faster and adapts much faster, generally, compared to the EU. I heard, and maybe you can cross-check and correct me if I'm wrong, that they are developing 5 next-generation nuclear factories specifically for AI. Therefore, yes, the environmental impact of AI is a big issue, and it is being tracked. However, as is the case of the knife, you can use the knife to spread butter, but you can also use the knife to kill. So it is the same thing, that AI can be used. It is a tool that consumes, but it is a tool also that can help us save. And somewhere there, in the AI cost equation, because it's also the financial, it's not only the environmental, it's also the financial. And so I would ask the gentleman who asked this fantastic question to check the MIT AI cost equation that brings everything all together. So it is a very hot topic that is currently under research as we speak.
Okay. It was Rosina Giordano, not a gentleman. Just
Rosa, my apologies to the lady.
And now from a gentleman, Uberto Di Pasqua, one more question. While the positive externality of AI on the economic and environmental pillars are very clear, I'm wondering about what specific and measurable steps businesses must take in their AI development, just a moment, AI development and deployment strategies to demonstrate a positive contribution to the social pillar of sustainability.
Wow. So Mr. De Pasco asked a very, this question encapsulates pretty much everything. And it depends on the level of AI readiness, and it depends on the level that, of course, encapsulates everything else. And of course, it depends on the level of AI maturity within the organization and, of course, the AI application. Therefore, before an organization or business decides to apply or adapt AI into their practices, even more so to reach the level where they are transformed by AI, which is the latest, let's say, step, they need to sit down, relax, consider, analyze, and see what they can do, what they should do, and to avoid those lies of AI that I mentioned, and map out the possibilities and start step by step applying, first of all, by experimenting with AI, piloting phase, and this is actually a step that many businesses fail, let's say, to transition to the next steps because it's not easy, and then slowly to move into their own solutions all the way to AI transformation in the end. So I would take it step by step. Get all the ducks in a row, assess the level of readiness, assess the level of capability, understand what data you have. If you don't have data, then you cannot employ your own, let's say, AI solutions, but you can actually use AI to speed up your processes, such as brainstorming, data synthesis, analysis, marketing, prototypes, and so forth. So depending on the level of maturity, and you'll take it from there.
Okay. Thank you. Also, Ms. Rosina says she will check the MIT cost equation for AI.
Cost equation, yes. A generative AI cost equation.
Yes. And also thanks for Mr. Roberto, and thanks from Marika Lahti. This was really interesting presentation about the matching points of AI and design. Also, thank you for the insightful session from Mr. Stylianos Georgopoulos.
Thank you very much.
I don't know if we should wait for another question, or maybe we can finish the session?
It's already 1 hour and 25, almost 25 minutes. I mean,
Yeah.
it was
Yeah.
quite long, let's say, presentation. So if
Okay.
But I
nobody
stopped
has any questions.
exactly in 1 hour. I don't know. I have the clock here. It was like on the second.
Okay.
Okay.
So any more questions, anybody? Or on the chat, or
I suppose that if someone needs something to ask, Tommy, thank you. Tommy said, thank you for the session, very inspiring. I think
Thank you
that
very much.
they can connect with you. They can ask if there is
Yes,
something.
feel free to connect with me on LinkedIn. I'll be happy to connect.
Okay. Okay. Again, I would like to thank you on behalf of the Regional Development Fund of Central Macedonia and International University. And thank you all for participating. Also, Mr. Kostas Zapounidis said thank you. So thank you for interesting session. And it was very interesting, very fruitful, and waiting for the next one. Thank you for the rest of
Thank you
the
for the honor. Thank you for the invitation. It's always a pleasure.
thank you very much,
Thank you
Fotis.
very
Thank
much.
you all for
Have a
participating.
good day, everyone.
Bye-bye.
Okay.
Thank you very much.
Bye.
Thank you for this. Bye.
Thank you.
Bye.